Welcome everyone. Thank you very much for joining us this morning. My name is Mike John. I am head of technical delivery here at the Sempra Group. My job is very much within the realms of delivering solutions for our customers when it comes to the world of metrology, smart manufacture, and data collection. So I'll be talking today about smart manufacturing, what that means, how you can develop it within your own company, and what sort of aspects to that you're going to find as the challenges and maybe the solutions to those challenges as well. So moving on to the first slide. So the first question that I've got really is what is a smart factory? And there's lots of definitions, but the definition that I found the most appropriate is the one that we've got on the screen at the moment, where it says it's a digitized manufacturing facility that uses connected devices, machinery, and production systems to continuously collect and share data. So that's the first aspects to it. And of course, you've got some of those words which are made in bold: digitized, collect, and sharing data. So that's the first aspect really for a smart factory. However, the second aspect, in my opinion, is the most important, which is this data is used to inform decisions, to improve processes, as well as address the issues that may arise. So as we kind of see, a smart factory is not smart because it tends to talk to each other. It's the data and the decision making that you can create from that data which makes it smart. It's not the be all and end all really in terms of the actual physical aspects of it. So when you're striving for a smart factory, it's not the final solution. Having everything implemented is not the end. It's merely in many ways the start. So it's if we've got this kind of flow chart here in terms of the expectations is you invest in new technology, you connect it all together through IoT, you collate it into a database and something, and then profit, and then reward, outcome. So what is that question mark bit? I think that's the little bit we find a lot with our day-to-day here at Sempra, is that the bit after you get the collection in the database is the bit that's kind of missed. And actually what happens is you've got all this data, but you're not actually doing anything with it. You're just collecting it and putting it over there and going, we've done it. But then the actual problems aren't necessarily being dealt with. So at this point here, I normally ask, who here is kind of striving for a smart factory, and where are you stuck? Are you stuck? Where are you stuck? What part are you in it? What are you trying to get from this process of moving towards smart manufacturing? And which part are you kind of stuck with? Now, it's difficult on a webinar, but I think it's good to mull that bit over whilst you're kind of listening. Is kind of going, well, if you are on this journey, maybe you're right at the start, maybe you're near the end, maybe you're having problems with it. Which bit are you at? And does this kind of is what I'm talking about here? Is it similar to what you're experiencing at the moment, and why that could be? So what I'm going to do now is I'm going to talk a little bit about a process that you can kind of follow in order to kind of go from the very, very start, no smart manufacturing at all, to smart manufacturing. Now, this is a broad plan. It does not give you all the answers. It tends to give you all the questions more than anything else. So we'll start with that first. And this first step that we like to talk about here at Sempra is your outcome, or outcomeology. I hear quite a lot knocking around, which is that oftentimes we tend to get stuck in the problem without necessarily thinking about what the outcome to that problem needs to be. So it's not that, for example, we've got, you might see like an issue of, let's say, high scrap rate. So you tend to get bogged into the problem of how can we fix that high scrap rate, when actually the outcome that you're seeking is an increase of productivity, maybe. Maybe you've got high overheads, so the business isn't performing as well as you'd like it. So how can you actually increase the efficiency and reduce your costs? Now there's lots of different aspects to here, but what I'm trying to get to is it's not necessarily the problem that you are seeing, but maybe there is a larger overarching outcome that you are seeking. And that will take different aspects in terms of maybe the production issues, maybe there is profitability concerns, maybe there are lots of different things kind of coming into that. And that will actually form the opinion of the outcome rather than solving the problem. Because it's reasonably straightforward to solve a problem. If you need to reduce your scrap rate, you can just spend more time and more cost in getting it right. Is what you want to do. That could be a solution, rather than monitoring where the actual problems are coming in. Are they coming in at a particular time, on a particular machine, with a particular person, with a particular skill set? Who knows? Unless you know that, you couldn't possibly act on it. And so the outcome that you're seeking is actually higher productivity, maybe. And that's the thing that you kind of want to focus on instead of focusing on just the problem itself. And this bit we tend to find is quite tricky because it does require some cross collaboration with different departments. It does require a good amount of thinking, but we find that if you have this aspect in your mind as a very clear objective of the outcome rather than the problem that you want to solve, we find that the rest of everything else kind of comes a little bit easier. Just because you know more than anything else. And so once you've kind of come to your outcome in terms of what you want to improve, what you want to achieve through what you see as a problem, you can kind of move on to the next stage, which is to consider how are you going to do that. So once you have your outcome. And there's something that we kind of use, or I think is very good here, which is a process for process improvement that we know of. And it's basically asking if you've got the right tools. But the interesting thing I find about this process for process improvement is generally that in order to go through this process, you've got to have some sort of data, some sort of insight, some sort of understanding of what you're doing or what you're looking at before you even go through this process. And so it's understanding what tools you need to get. So the first question that we tend to think is your process in control? You think, well, if you don't have any data to back that up, how could you possibly know that it's not in control? So a lot of the time, the stumbling blocks on the first question, which is it in control? Or we don't know, we don't have the data. So how do you get the data? So that first aspect of this, of trying to move towards your outcome is how do we get the data that informs the decision that will inform the problem for that outcome. And once you kind of consider that, you kind of start to realize actually, okay, you kind of start to get it a little bit. So is the process under control? So if you take your data and you go, no, it's not under control, then there's a number of methods and techniques that you can use to bring it into control and make it more stable. So if it's not in control, you look to stabilize. So you can use SPC, statistical process control. You can use a number of manufacturing techniques like 5S in terms of making it more efficient. It could be demand smoothing in terms of looking at where your products are going in and out and when that happens in order to accomplish that. If you find out that the process is in control, or after you've stabilized it, it is in control, have you actually analyzed it? Have you looked at your process? Can you look for insight in terms of efficiencies? Can you look for insight in terms of what's happening? A lot of the time we get customers saying we've got bottlenecks. At that point, they obviously analyze the process to know that that's where the bottleneck is. But if your process is under control and it's not been analyzed, then that's the next step, is to analyze it. In terms of you look to map the cause and effect, you've got things like 5 Whys or FMEA. There's lots of tools out there to help you. However, with all of this, sorry, I've missed a part out, sorry. And if your process is under control and it has been analyzed and you still can't really see anything to kind of improve in general from a process, then what you're actually looking at is something more like an incremental or indeed a radical change. So let's say you've been using an example I use is that a customer we had a few years back have three grinding machines which were about 106 years old. And they work perfectly fine. They've been working perfectly fine for the past 106 years. However, as you can imagine, they are not up to the standards that you would expect in today's sort of manufacturing techniques. And so the radical change was to completely revamp the entire process of that cell. And that can be quite a radical change for a lot of people, because it might reduce the amount of operators that are required on a shift. It might increase the requirement of skills, but there is then a lot more benefits that you can draw away from that. And again, incremental change as well is an aspect in terms of we're going to just start bringing other aspects into our process. But all of these steps, the understanding if your process is under control, understanding if it's been analyzed, all the data that kind of comes with that, they all have these applicable tools, which is data collection, these sort of smart quality benches, shop floor metrology, and things like quality planning. So all of those aspects in this process for process improvement can be affected or can be brought together through these sorts of tools. And again, the image I've got on the right there is that when you're looking at this process, you need to also understand, as part of your outcome, the kind of ethos that you're also bringing in terms of your actual product, because I'm sure you've all seen this before. You can either have a good, fast, cheap. Choose two, essentially, because you can't choose fast, good, and cheap. It's not going to work. So all of these need to generally be understood in terms of how does that affect it, because if it's cheap and it's good, you need as much of the analysis every time. If it's good and fast or whatever it might be, do you actually want to renege on the quality aspects of here? And what you really want to be doing throughout all of this really is taking all these in together. So this aspect here, in terms of considering your approach, often is the most time consuming, because you're usually finding a different technology, you're looking for solutions which can help you gather your data, etc. Once you've got through that aspect of understanding what approach you need, understanding that we need data here, we need to analyze this and everything else, then you're going to start to look for solutions. You're going to say, right, okay, how can we get to stabilize our process? How can we analyze our process? What tools do we need in order to do that? And how does it fit within that aspect of, do we want it to be really cost effective? Do we want it to be absolutely robust? Do we want it to be fully automated and future proof? Those aspects really. That a lot of the time, that's where we find a lot of our customers come to us. They've kind of gone through this journey or a journey, and they're looking for the solution. But we do often see that the steps 1 and 2, they haven't necessarily been thought about. So they're coming in from we can't measure this, or whatever it might be, this feature, this part, and we need to measure it, whatever it might be. It's more of we have a problem to solve, rather than we're seeking the outcome, which might be, instead of we need to measure this part, it's our customer or our clients have expectations or standards that we currently can't meet. It's a slight paradigm change, subtle maybe too subtle in many ways, but important, as we see. But when we get to things like finding the solution, for example, if you've got quality bottlenecks, clients will come to us and they'll say, right, okay, how can I deal with this? If you've thought about the outcome and the approach beforehand, in the terms of we need data and we need it fast and we need it on the shop floor, then it becomes a lot easier to find a solution, because you already know what the problem is in many ways. And the problem is bigger than what you think it is. So there's a number of aspects of the solution, and again, it depends on the outcome. Things like, as you kind of see here on the left-hand side, in terms of what the problem might be and what the outcome might be from that. So if you've got quality bottlenecks, you might want shop floor metrology. If you've got performance issues where you can't necessarily keep up with the demands of clients, maybe you need an expert like Sempra to take some contract measurement from you to help you with that process, and maybe even as an aspect of trialing different technologies whilst being in production to understand what you may need, because you may not. Have you got long-term production? You're looking at this is going to be a 10-year project, and you need to understand how to control your process going forward. You might look at inline metrology solutions. So rather than having it sat in a quality lab, it's in the machine that's creating your product already. And really what we're looking at for here is, or this aspect is what we're looking for, is insight. That's kind of where we're getting for, is that once you've got your what the outcome needs to be, you understand what insight you're going to need in order to affect that change. And where this aspect comes in terms of the solution, it's more about the technology that will help you get to that, rather than just, here you go, it's a box, it's a machine. We're not talking about that particularly in terms of it's a machine. We're talking about implementation of technology, and that's the next step, which is implementing. And this is a very, very short slide for what is generally a very difficult step of the process, which is implementing a smart factory. It sounds very simple, doesn't it? Just implement it. We've got a nice shiny thing, now let's go and implement it. But it's not that, because it's the actual smart aspect of a factory doesn't solve your problems. It just gives you the data. It gives you the insight to be able to know what the problem is and where it is, and then to do something about it. And this bit generally we find is the aspect where customers will struggle the most, because it's not about just the one problem. It's not about a particular issue on a production line. There's other aspects in terms of things like stakeholder management. Like IT can be a massive issue, because there is a structure within IT which says we have this, and if you bring in a software or data collection software suite to help you, the implementation of that might not be as easy to link up with the IT expectations of security and everything else that you would like. And that can often be an issue. So getting people like IT involved, bought into the process, is a massive step or a massive aspect of achieving the goal of a smart factory. And so supplier selection, having the right suppliers in your back helping you with this, having the right champions internally, so having someone who owns it, who says it's this, go and do it, it's everything around it is yours, you have to champion it through. If you have that within the company, because there's going to be pushback internally, as there always is with change, there's going to be pushback internally with this. So someone needs to be internally championing this and believing that this is the way forward. If you don't have that internally, it's going to be so difficult to actually implement change, and having that is really key. Oops, I'm not sure process.
All of these services really help
dream big, start small is something that we do as well. So a lot of you come in and say, we want to do this, we want to change everything in the factory worldwide. You go, fantastic, we can help you with that. However, don't go for everything all at once. Go for part of your cell, a cell in a factory. Then you can grow from that cell to a division. From that division, you can go to the entire factory. From that factory, you can go multi-factory. But you dream big, you start small, you do it in increments. You break it up into manageable, actionable tasks which have an outcome which you will realize much quicker than the whole thing. And it tends to be a kind of thing. You say dream big, fantastic, but just start small. Understanding skills development. So if you are bringing change into an organization, like new technology, you need to think about the people who are going to be running this. Do they have the right skills? Do they have the right attitude to this? Is there development that needs to be occurring around that in order to make this a success as well? And then finally, a data insight plan. So if you, through the other three steps, you've kind of understood what your outcome is going to be, how you're going to get this insight, and what insight you're expecting, and then you've looked at a solution to try and bring that in. What are you going to do with that data? After you've got it, what are you going to do with it? Now, you might go, well, we don't know until we don't know. That's perfectly valid. But you need to be in the mindset that once you've brought it all in and you've got this data that you're going to action on that data. It's going to give you insight. How are you going to manage that going forward? It's a continuous improvement process, essentially. And that's kind of the thing that is the next step in many ways. But you need to think about that before you get it in, more likely. And then finally, really, this is the crux of it, of a smart factory, is the informed decision making and then refocus. So the step here I've got is shamelessly stolen from a sci-fi book that I very much enjoy, which is that if you have data, you can get insight. If you get insight, you can get control. And if you have control, you have power. And that really is what we're talking about here, is that through the acquisition of the correct data, you can have the power to make the decisions and make it knowing that it's going to make a difference. And that is really the end goal of this entire smart factory. We've got everything involved. It's nice and shiny. Everything's blinking red and green lights. But that's not it. You then have the data. Now the problem is, how do you go about talking about it? And there's again, I'll harken back to a customer that we had a couple of years ago who did just this, and they had an idea of exactly what they wanted to do. This is the same customer that was the grinding machines for an aerospace application. They replaced their old machines with brand new ones. They brought in they replaced all of their gauges essentially with automated metrology systems and fixtures, and the data was all being collected and it was being analyzed. And this is for an aerospace application where 100% inspection is often key, but also what it allowed them to do was understand when the redressing of the grinding wheels needed to occur. Because you can see as we're going along, it's trending towards going out of spec or out of control, and they can see it, so they knew that generally within a couple of days or a couple of hours or whatever the number was, that they knew that they would have to redress it after a certain number of parts, so that every single part was passing, rather than, oh, it's gone out of spec, what do we need to do? They could then anticipate the problem rather than react to the problem, and that to them was incredibly powerful, because then it made them super efficient. And this is a product which is it wasn't a new product, it was an ongoing product, but then it's just essentially sat in your factory. It's creating a revenue stream which is going to be okay, and if any issues occur in terms of quality issues, you've got the data immediately to hand. They can pull straight off of the server and hand it to their customer and say, this is our quality control. Everything became smoother. But it wasn't necessarily the implementation. It wasn't the products that did that. It was the attitude, the implementation, and the accepted fact that the plan, do, check, act, continuous improvement type philosophy is going to be brought in throughout the next 12 years or whatever it might be. And so with that, I just wanted to give a quick demonstration of what we're meaning about this in terms of what you can see if you came to Sempra, which is a smart manufacturing demo. So, and this is just a very quick demonstration in terms of what you can do. So this is something you will see internally at Sempra. We have something called HiQA, which is a software which allows us to automatically balloon and create inspection plans for our components. This component is one that we've designed and made ourselves. And it allows you to, I said, automatically balloon your drawings. It will produce an inspection plan, and then you can go and manufacture it. And this chap here is currently manufacturing some stuff on our machine tools that we have here at Sempra. And so we're going to manufacture it. We would then laser engrave the system with a serial number and traceability information, as you can kind of see here. We'd then pop it onto one of our microview systems, which is an optical CMM, which you can see is automated. So you pop it onto a fixture, you press go, and as it's running through, inspecting the component, all of that data, which is traceable now because we've got a serial number on it and a QR code, all of that data is then brought into the system, and then it's automatically exported into something called DataLyzer, which is a kind of a data collection and analysis software. And you can see as I'm going through here, you'll see in a minute that a new record has come through. So all the data that we're taking for these parts is being recorded automatically through the data collection, but also then from an analysis point of view, You can then go and find all the parts that you've done, bring it back into high QA. You can then analyze what you're seeing. So the little flags that have gone green are green because it's passed. And then you can go and create automated inspection planning reports from this. So you press create report, and this is an AS9100, so typical aerospace form 1, 2, and 3, and it's automatically here. It's automatically been populated with the right information. So very quickly, I mean, this is just a 2-minute video, but very quickly you can see how we've managed to create something. We've created, we've manufactured it. We've created inspection plans for it. We understand what needs to be measured, and then we're able to collect that data. We're able to then draw insight from that data in terms of, okay, we need to change the setup, we need to move it here because the conspicuity is out, whatever it might be, and then we're able to then analyze it even further in terms of producing compliance or regulated compliance documents based on that data. So like an AS9100 or a PPAP or whatever it might be in terms of what you need. And that's the kind of technology that you can use to implement a smart factory. You'll notice that the only bit there that is the machine tool, which is the bit that's actually making it. Everything else is kind of around it. But it's a typical way of visualizing how a smart factory actually is. It's not the manufacturing bit necessarily, it's the bits around it which support it. And really that kind of brings me to the end of what I'm talking about today, and I'm just talking about now in terms of how Sempra can help in that. So we talked a lot about today about there's lots of generic business processes in there in terms of understanding your approach, understanding your outcome. The solutions aspect was only one slide of this, along with the informed decision making, along with the demonstration. So really it's a lot about the questions, and where we can help a lot of the time is the fact that we do this regularly with lots of clients. So we tend to understand the questions that you need to ask more than the solutions to those answers, or answers, for want of a better word. I'll start again. You'll come to us, we'll probably ask you questions you didn't know to ask, and then once you go away and come back with the answers to those questions, we can generally help with you. And that's the important aspect, is getting the right understanding of the right questions. So we help you discover your outcomes, we help you understand the data, and we can basically kind of help you, guide you through this process, through the application of technology, through answering the right questions, through the expertise that we can give. And that really is the thing that kind of we're looking at. So I'm going to end it there for us. So thank you very much for your attention. If you do have any questions, please do feel free to ask. If you are interested in getting in touch for a conversation about anything I've talked today, the QR code is on the screen, or indeed just give us a bell, call or email, and we'll be more than happy to have a conversation about smart manufacturing with you all.